Now we're going to take a look at number 14. It's estimated that 75% of a grapefruit crop is good. The other 25% have rotten centers that can't be detected unless we actually open the grapefruit. Grapefruit are sold in sacks of 10. I'm noticing that this seems binomial to me. We might be able to say that n is 10 for our fixed number of trials. We could call success a good grapefruit, and then the probability of success would be 0.75. If we're talking about a sack of 10, and I'm looking at part A, it does say that this is binomial. I'm being asked to create this distribution for the number of good grapefruit. So again, if there are 10 of them, we could have anywhere between 0 and 10 that are good. So 0, 1, 2, 3, 4, 5, 6, etc. for my R values, where I'm looking for the probability of R successes out of N trials. And then to fill in these probabilities, I'm going to go to my calculator. And I could use the formula to do this by hand, or I can use Binom PDF. So that's second vars alpha A. And we have 10 trials, a probability of success of 0.75, and I'm just going to go down the line for each of these. So I'm going to start with 0, and I get a number that's in scientific notation, so I'm going to have to convert that. So when I'm converting this from scientific notation, I'm going to move the decimal place 7 spaces to the left, which means I'm going to have 6 zeros, and then the rest of these decimals that were there. I'll go out to here. Okay, so it's a really low probability that you're going to have no good grapefruit out of the 10. So now let's do it for 1. So second vars, alpha A. Luckily that stuff's all in there, and I'm just going to change this to 1. And I get another thing in scientific notation, and again I'm going to have to convert that. And when I'm talking about the conversions here, I'm not converting to percents, I'm just converting to standard notation. If I was converting to percents, I would have to move the decimal place back 2 places to the right. So here in this one to convert, I'm going to move the decimal place 5 places to the left. So I'll have 4 zeros, and then the decimals I had before, and I'll round it off there. So again, we're seeing that this is a very low probability. Now I'm going to fill in the rest of the table. And it's not until I get to 3 that I get a probability that is not given to me in scientific notation on my calculator. Right now we're looking at a probability of about 0.3% if I was going to convert that. All of these others have been significantly smaller, but this one's about 0.3%. So still a really low chance. And when we get to 4, this is the first time we're seeing a probability of even a 1% chance. So we're seeing as we get into these higher numbers, the probabilities start to grow that we will find bad grapefruits. So we're finding the probabilities right now of this many grapefruits being good. So I just plugged in 7. The probability that 7 of the grapefruits will be good that's about a 25% chance. And if you look at those lower numbers, like the probability that none of them will be good, that's pretty much really close to a 0% chance when we're rounding that out. And then even that only one of them is good is very low, that 2 of them are good is very low. So we should start to see as we get to these higher numbers, that the probability of most of the grapefruits being good are going to be higher, and that's because our probability of success is so high at 75%. When I get to 9, I see that my probability starts to go back down. It looks like 8 good grapefruit has the highest probability, and then I imagine 10 will also decline because there is still a chance of finding at least one grapefruit that's not good. But looking at this distribution without graphing it, I would say that it's definitely skewed to the left because those lower numbers have lesser probabilities, and then as we get to the higher numbers, we see the higher probabilities. So that's my probability distribution. And now I'm going to answer part B. What's the expected number of good grapefruit in a sack? So I'm going to use mu equals n times p because this is binomial. My n was 10 and my p was 0.75. So that's going to give me 7.5. And we see between 7 and 8, those are the two highest probabilities. So we would expect to have 7.5 good grapefruit in a sack of 10. And then in part B, I'm going to find the standard deviation sigma. That's the square root of n times p times q. I already know n times p is 7.5, and then I need to multiply by q, which is the probability of failure. So I'm going to do the square root of 0.25 times 7.5, and I get about 1.37. So the standard deviation of good grapefruits is 1.37.